Next question's from Zenuru. Got a technical question for you. What led you to choose the Cloudoid interprocess package over other cross-platform IPC libraries? I started using myself, but the lack of any async methods could almost make it feel inefficient to be constantly polling while through loop. So there's two parts of it. One, you don't actually need to be constantly polling in a while through loop. That's like it uses something called like busy spinning. So that's the while through loop where it'll like spin and check like a few times, but if it like doesn't get anything, then it actually waits on a semaphore. And the semaphore is like using like one that's global between different processes. So like if it doesn't get anything for a few spins, it'll sleep for a bit and then like it'll wait on the semaphore. So when the other end, like, sends some data, it also triggers that semaphore and it wakes that up. And that actually is what makes it efficient. And so I actually work like on making this also work like, on Linux, like across like, the Windows and Linux. Like, I don't know if you do want to talk about that part a bit.
Yeah. So the way that you can like, so firstly, I do want to expand a little bit on like the way that you can wait for a message on the other side. Like you can literally just like shove the like read message like function, I forget what it's called, in like its own thread. And like Froox said, the semaphore will actually like it'll actually halt the execution of the thread until it receives more data, so you don't have to like do the busy spinning yourself. It already handles that super efficiently. In terms of getting it to work on Linux, that was definitely a little fun because I had to make like a shim library to let the wine process actually call and like get like data from native POSIX semaphores because wine has to implement a lot of these sync primitives itself because Windows has very specific behavior that it needs to mimic for some of these primitives. But the semaphores, those work pretty much the same, honestly. And so just letting the wine process call into the native POSIX semaphores was a kind of sorry, I'm like losing my thought here. It was definitely a little bit of an adventure because trying to make a Windows process talk to a Linux process and actually see all of like the stuff. The shared memory actually worked perfectly fine. It's just the semaphores that needed to work. And I think one of our community members, I can't remember your name, I'm very sorry, made like a prototype like Rust library for it that I referenced. Yeah, we have a very unique architecture now where we have shared memory and semaphore communication between two entirely different operating system architectures on the same machine, which is really cool to think about. I can't think of any other
you have to use like the wrapper like. Yeah, like very like unique. I think I have to use like the like wine lab thing, like where you can actually like expose some like Linux like essentially Linux like kernel like resources like to the Windows applications.
Yeah, so like that was also fun because I had to write this as like a wine like quote unquote native library because wine will implement some of the Windows libraries itself in POSIX code directly rather than relying on the emulation. Or it's not an emulator. It's not an emulator. I'm sorry. It's not an emulator. Sorry, I almost called it an emulator.
You're gonna be expelled from the Linux community now.
Yeah. But yeah, no, like it's very cursed to reference both the POSIX standard libraries and the Windows libraries in the same project and make like Windows function signatures with like Linux code inside. It's very scary, but it works, and it works perfectly.
Yeah, but in general, it's actually more efficient than you think. Like that's like the while through loop is only like because the assumption is sometimes like the message will be being pushed fast because waiting on a like on like a semaphore while it's efficient, it's not as efficient as not doing it in the first place because it requires the transition, the control from the program like back to the operating system thread, and then like it needs to wake it up, and that will consume like a fair amount of like CPU cycles. Not like a huge one, but like a lot if you do it a lot. So if there's like messages coming, that's why it does the busy spinning, because say like it takes like I don't know, say 10,000 CPU cycles, to transition from the program like and wait on the semaphore. It might spend like 1,000 cycles just kind of waiting, because if something comes within those 1,000 cycles, which can be very likely for like something that's like frequent communication, then it doesn't need to like you don't need to take the cost of the 10,000 cycles to like transition. But if nothing's coming in that time, then it's just it frees the CPU resources. It may be wasted like 1,000 cycles, but that's not a huge deal. It waits on it, and then like it gets woken up. But if something comes within those 1,000 cycles, then like you saved like even more. And it's general like philosophy behind like busy spinning. But in terms of like what led us to choosing this library, it seemed like a good fit. Like it had the stuff we needed. It didn't have like a lot of bloat. We're kind of looking for shared memory. A lot of the IPC libraries actually didn't use shared memory. They were like using like pipes and other stuff, which we specifically didn't want to use. And it also like was open source. It was the like license that we can use. So there are a few things missing from the library that we needed, because we also needed sort of like raw access to the memory. So we modified the library to kind of expose those things. Because it has the queues, but also has like just general shared memory primitives, and we just made like some small modifications. So it was it just seemed like the best kind of fit.